Okay, we're going to do an introduction to probability. Probability is really just the likelihood of something happening. So what is the probability that it will rain today? And you could find the chances of that happening. There are three types of probability. There is a relative frequency probability, meaning it's a study or an experiment conducted to find the probability. So for example, if you had a coin and you flipped it 10 times and you got 8 heads and 2 tails, you could say the probability that the next one will be a head is 8 out of 10. Then there is a theoretical probability. We assume that all possible outcomes of a particular experiment are equally likely. So in theoretical probability, the probability of flipping a coin and getting a heads is 1/2 because you have 1 heads out of the 2 options. And then the last type of probability is subjective probability, and that's a probability where we don't have data or any way to tell what the outcomes would be. So it's just subjective. And an example of subjective probability would be something like, what is the probability of a meteor hitting the Earth? We don't have data for that, so we wouldn't be able to actually calculate the probability. So we just have to use subjective questioning. In probability, we have a formula that we can use to find probability. We're going to say probability of event A. Probability of A is equal to, so the number of ways event A can occur over the total possible outcomes. So for example, if I have a dice, a plain 6-sided dice, and I want to find the probability of rolling a 3, think how many 3s are on the dice. In this case there is only 1 3, and there are 6 total sides, so the total possible outcomes are 6. So the probability of rolling a 3 would be 1/6. If you are rolling a dice and you want to find the probability of rolling an even number, think how many even numbers are there? There's 2, 4, and 6. So that's 3. And there are still 6 possible outcomes, so the probability of rolling an even would be 1/2. So knowing that the probability of any event is equal to the number of times that event can occur divided by the total number of possibilities, we can combine those into finding probabilities of multiple events occurring. So let's look first at the probability of 2 independent events occurring. An independent event is where one event doesn't affect the outcome of another event. So examples of that would be like flipping a coin. One flip doesn't change what's going to happen on the next flip. So let's say I wanted to find, I have a dice. I have a dice and I want to find the probability of rolling 2 6s. So 2 6s in a row or together, it doesn't matter, it's going to be the same probability. So in order to find the probability of 2 independent events, you just multiply the probability of A times the probability of B. So the probability of rolling your first 6 would be 1 out of 6. And the probability of rolling the next one as a 6 is the same, 1 out of 6. Because this 6 being rolled does not affect whether or not this one is going to be rolled. So then to find that probability, 1 times 1 is 1, 6 times 6 is 36. So you can do this not just for two, but multiple events. So what if I wanted to find the probability of flipping a coin and getting 4 heads in a row? So we would have the probability of getting the first one as a head is 1/2. The probability of getting the second one as a head is 1/2, because what happened in the first event doesn't change what's going to happen in the next one. So the third one would be 1/2 and the fourth one would be 1/2. So we multiply each of those and we get 1/16. That's interesting that you have a higher likelihood of getting 4 heads in a row than 2 6s in a row. And that's because there are more outcomes on a dice than there are on a coin. So now let's look at what would happen if the events are not independent. Let's say that we have a dependent event where you have 1 or 2 or more events occurring at the same time. A dependent event is where the outcome of the first event causes the outcome of the second event to change. An example of a dependent event would be drawing cards. If you are trying to find or draw kings and you draw a king in the deck of cards, you have less kings left in the deck. So instead of saying there are 4 out of the 52, the first event would happen, you would only have 3 out of 51 cards. So the probabilities change because the event before it happens. The probability for dependent events is fairly similar to independent. However, you have the probability of A times the probability of B given A has happened. So this right here means the probability of B given A has occurred. So let's say I want to find the probability of drawing 3 kings. Maybe you want a 3 of a kind or something. So the probability of drawing 3 kings. Well, there are 4 kings in a deck. So for my first event, the probability of A, I have 4 kings out of 52 total cards. Then we're going to assume event A has happened, and to find the probability of the next king, there's going to be 1 less king in the deck and 1 less card in the deck. And then to find the next king, there's even 1 less king than that and 1 less card in the deck again. So then you would just go and you'd find that probability. It reduces a little bit, so let's write the reduced thing here. 4 goes into 52 13 times. 3 goes into 51 17 times. And 2 goes into 50 25 times. So you multiply those across, and we get that the probability then of drawing 3 kings in a row is 1 over 5,525. So that would be the dependent probability. So you see, the most important part on this is that the probabilities change based off of what happened before it, whereas the independent events, they did not change.